how do we help try and catalyze more of a spatial systems approach to innovation in Rhode Island? So the idea of the Blue Green Challenge was, one, it's tailored for Rhode Island. So we really wanted to emphasize students, design thinking, as well as some of the priorities and issues that are facing Rhode Island, Providence, Southern New England. And hence that is how we came up with the name Blue Green. So if you're looking to electrify and reduce carbon and ground-based emissions in your urban transportation, why wouldn't we maybe look at your working waterfront? If you're looking to reduce urban food waste or circular economy, big topics globally, nationally, how does that specifically apply to Southern New England with Narragansett Bay and seafood? So that is essentially how this Blue Green Challenge started. And thank you to our sponsors. And what we will hear from is the actual finalists present, and you'll get a whole diversity of different agendas and ideas. And I'm going to hand it off right now to Alyssa, who's going to walk through the actual schedule, as well as acknowledge our sponsors. Thanks.
Great, thanks, Mark. I will just start out by saying thank you to our fantastic sponsors who made this program possible and who made the awards that we're going to be giving later to the teams possible as well. Taylor, could you go to the next slide? Thank you. So I just wanted to take a moment, introduce myself and introduce SeaAhead so you could better understand where we're coming from and why this challenge was so interesting for us to get engaged in. So my name is Alyssa Peterson. I'm a co-founder and executive director of SeaAhead. And SeaAhead was launched and founded in 2018 with the mission of catalyzing innovation that would support ocean-related health and sustainable ocean industries. And we do a number of things. So we have an on-ramp for startups that are interested in engaging with our community, which includes our Blue Swell Incubator. It included challenges like this and our startup membership. We support those startups and innovators by connecting them with mentors and advisors with a larger economic cluster of folks that are working on this space with partners, including National Grid and Oyster and Waterson Terminal Services and the other corporate partners that are part of our community. And we also facilitate investments. So our Blue Angels Investment Group is our angel investor group, and then we're also developing a fund as well. And so with something like this, with a challenge, part of the reason this is so exciting for us and so interesting for us is that it's a way for us to connect deeper into and earlier to innovators that may not have realized that they had a stake and a role in ocean-related sustainability so that they can apply their big ideas into this sector. Could you go to the next slide? Thanks. So when we were looking at setting up this challenge, we focused in and honed in on three key aspects that are basically assets of the Rhode Island and Southern New England economy. And so the first is this combination of ports, urban electric mobility, and electrification. The second is renewable energy. Of course, we've been talking about offshore wind all day, right? So there's renewable energy. And then there's this combination of the local food, energy, water nexus. And so if you look at all of these are strengths within our location in our community. And what we did is we asked the students and we challenged them to say, what could you do that would happen at the intersections of these concepts? So not picking out just one, but looking at the intersections to try to find ideas that would draw these concepts together to create ideas that others aren't thinking about today. So what could we find that would be novel and useful within our communities if we looked at the intersections? And then once we've found ideas, to connect them with the stakeholders and to get them to devise these concepts in a way that the local community could then implement those. And so that was our challenge to the finalists. Could you go to the next slide? So what we aspire for the outcomes of this program are not just that, I would say there's a number of outcomes that we're looking for. One, we would like to see that there's an increase the availability of clean and sustainable energy in Rhode Island, and that we can enhance the sustainability of local seafood systems from boat to farm and plate. And that we can, as we were talking about earlier when Useful was on, which is one of our startup members, we could promote the circular economy, improve community resilience, right? And so when we talk about community resilience, that includes economic empowerment, includes health, and it includes food security. So wrapping all these things together, we were looking to inspire the next generation to solve problems that really matter. And so, if we think about these in total, we aspire that some of these programs and projects that the students have put together, that they will be implemented. And so when we talk about implementation, it's not just, a startup would be a great way for some of these folks to bring their ideas into the world, but it could also be a partnership. It could be one of the partners that are here today implementing these ideas through their channels. And so as we close this program, we'll be talking more about then how to take this to the next level. But today is really all about the prizes. So I will hand this back over to Taylor.
All right, thanks, Alyssa. Hi, everyone. My name is Taylor Whitkin. I'm the program manager at SeaAhead and have been managing the BlueGreen Challenge for a while now. Alyssa mentioned wanting to inspire the next generation of innovators. So I just wanted to go over what the value that we were hoping the BlueGreen Challenge would give to them. Throughout the challenge, we worked to connect them with mentors within the SeaAhead community and the Rhode Island community. That meant connecting them with some of our startups, which was really great to see. We are obviously really excited to award some money today. We have $16,500 worth of prizes to hand out to the first, second, and third place finalists. And then we'll also ask our audience here today to vote on your favorite and award the final $500. We're also really grateful to CIC Providence for providing access to their co-working space. This has really obviously been a tough time during the pandemic. And we hoped that CIC would get a lot more use, but we were encouraged to see that some of the teams, I think some students from Brown came down the hill and were able to meet and work here. And then also, as Alyssa mentioned, there's an opportunity to work with our program partners and key stakeholders to hopefully implement these designs. We really see this challenge as the beginning of things. I think Rhode Island has a pretty great history of student-led innovation. The Providence pedestrian bridge, Farm Fresh Rhode Island were conceived by students. And so hopefully this challenge and the ideas that come from it can add to that legacy. So the challenge started a while ago and took a while to get off the ground because of the pandemic. But once we got rolling, it was really great to see the students working and developing their ideas. We recruited from institutions of higher education in Rhode Island, Connecticut, and Massachusetts. I think we had applications from 16 different schools, and I believe 7 schools are represented among the finalists today. And it was actually really great to see that some of the teams are made up of students from different schools, which was one of our intentions at the beginning. We weren't sure it was possible with the pandemic, but it happened, which is great. Finalists were down selected by SeaAhead and then chosen by the SeaAhead leadership team, our sponsors and collaborators in Rhode Island. Throughout the course of the challenge, we held bi-weekly check-ins with the teams to make sure they were on track, to answer any questions, and to also provide introductions to those key Rhode Island stakeholders. We also held a midpoint review session with each of the finalists. The SeaAhead team was there along with some folks on the selection committee. And we selected the finalists on Tuesday with SeaAhead and our sponsors in the room. So speaking of sponsors, I wanted to turn it over first to Brian Schuster, who leads customer and community management for Rhode Island with National Grid.
Thank you, Taylor. First of all, sound check. Can you hear me okay? I'm calling in on a phone. Yes. And I also have, okay, good. So first of all, thank you, Taylor, Alyssa, and Mark. This is certainly an exciting endeavor. We are very proud to be part of this overall challenge, as it were. You know, at National Grid, most folks think of us as, you know, just that utility provider that provides hopefully safe, reliable, and affordable energy. But we also are very focused and keenly aware of the need to be clean and cleaner in our energy services. So, you know, and we have a lot of different vehicles that we're pursuing, different clean energy aspects. Actually, we have an unregulated branch of our business called National Grid Ventures that does a lot of the innovative side of clean energy thinking. So it was kind of exciting for me, who represents the regulated side of our business, to be part of this endeavor, which has been certainly one of the most fun and exciting events that I've been part of here in the last year. So I just like to say congratulations to all of the participants, and certainly the award winners, if you were, but honestly, all of the entries were really exciting, fantastic, very innovative. And my applause goes out to all those that put in the hard time and effort for the different entries. So with that, thank you on behalf of National Grid. We're happy to be here, and I'll hand it back over to Taylor.
Great, thanks, Brian. Next up, we're going to hear from Todd McGuire. He is the managing director at 11th Hour Racing.
Thank you, Taylor. So 11th Hour Racing, we are an organization that focuses on the restoration of our oceans, and we're based here in Newport, Rhode Island. And what we like to do is that we use the mantra of think globally, act locally. So when Alyssa and Taylor approached us with the BlueGreen Challenge, it really fit into our mantra. And what we really liked was the fact that the challenge was working with the local university students and tasking them with these local problems, but really how they impact the global issues, such as climate change, sea level rise, ocean acidification. So for us, it was, you know, our small state of Rhode Island can really set a global example. The other thing is, you know, as an organization that focuses on ocean health, we felt that the challenge was going to make some direct connections to, you know, what happens on land and how it impacts the health of Narragansett Bay, and, you know, directly impacts the health of our ocean as well. And then I would say that, you know, the last thing is, you know, the university students are our future leaders. So the students, again, there were some amazing entries and challenges that were put in, and you're the ones that are going to be tasked with protecting the planet better than the last couple of generations have. So that, you know, that's a big reason for us. The other thing is, you know, we see this as an opportunity to invest in your futures, because you are the future leaders of this planet. So for us, that was the big reason. And again, want to thank Alyssa and Taylor and Mark for a great challenge, and, you know, look forward to seeing the presentations.
Thanks, Todd. And then last but not least, we have Rebecca Weber, General Manager at CSC Providence, where I'm sitting today.
Thanks so much, Taylor. I'm looking forward to seeing you later, and I'm also looking forward to seeing every one of the participants come through in some capacity in the coming weeks and months ahead. In addition to the congratulations that Brian and Todd presented, I'd also love to say thank you. Thank you for being so forward thinking and optimistic in light of all of the challenges of the last year, that these student participants were still able to focus their vision and their aspirations on things that will make the world more livable and more productive in the years ahead. So we're very grateful for that. Alyssa was referencing some of the geographic resources in our community, and we recognize that SeaAhead is a part of that community of resources that we have to offer here at CIC Providence and also CIC in Boston and Cambridge. We are so grateful that you call our location home, and we hope that some of these budding entrepreneurs will choose to call CIC home as they grow their businesses and their ideas as entrepreneurs with impact. Thank you so much, and congratulations to everyone.
Thanks, Rebecca. So before we get to the pitches, I just wanted to run through the criteria that we used to judge them. We obviously wanted them to adhere to our design guidelines. We asked all the finalists to keep their pitches to 4 minutes. We looked at the feasibility of implementation. Is this something that could actually happen? Obviously, as I said, this is just the beginning. So, a lot of work is going to need to go into making these visions a reality, but could it be possible? We wanted to see creativity and novelty in their ideas. We wanted them to address environmental impacts and ultimately have an positive environmental impact, as well as a positive impact on the Rhode Island economy, community, health, and hopefully social justice impacts. We also really looked for them to engage with stakeholders. So not only identifying the relevant stakeholders, but actively reaching out and asking for feedback from the relevant stakeholders, because they're the ones that are going to need to be involved if some of these designs were to move forward. So with that, we're going to get to the pitches. Just wanted to remind you that we immediately following, we'll be opening a poll for our People's Choice Awards. We want to hear from you which pitch did you think was best, and the winner will receive $500. So please keep that in mind as you watch. First up is Jason Walsh from University of Rhode Island and John Burley from Brown University.
Hello, I'm excited to share our submission to the BlueGreen Innovation Challenge. I'm John, this is Jason, and our goal is to kickstart the adoption of renewable energy in the Rhode Island maritime sector. We're going to show you the easiest first step towards this goal. It's a pilot program to convert an iconic Rhode Island ferry to use locally made biodiesel. The problem is bigger than ferries. The maritime sector is a major emitter of greenhouse gases and other pollutants that negatively impact human health and the environment here in Rhode Island and around the world. To illustrate it, this map shows airborne diesel particulate matter in Providence. Emissions from the port contribute to this red zone. Here, air quality is so bad that childhood asthma rates are far higher than the surrounding areas and the national average. Providence City has committed funding to reduce asthma rates, and this will include measures to decrease emissions in the ports. So this, combined with pressure from all levels of government to achieve carbon emissions targets, shows that there's a need for the maritime sector to change, to reduce reliance on fossil fuels and clean up emissions. If we convert a ferry to biodiesel, it will give visibility to an existing renewable fuel with lower particulate emissions. It will increase the availability of biodiesel to all marine users by creating a new distribution pathway. And we predict that this will drive innovation to generate biodiesel in new ways. To show you all of this, let's take a look at our model of the supply chain. The current situation is that over 75 million gallons of biodiesel are made annually from restaurant grease in and around the state, and this is mostly going towards heating homes. Here is a market sector that can be created by a successful ferry pilot program. A visible public example will create demand, and if users want biodiesel, mariners will get it from distributors. Note that biodiesel produced from wasted grease is marginally cheaper than petroleum-based diesel. But it's important to know that the grease supply is finite. This is not a problem for the pilot program, but it could become a problem for our longer-term vision. So for this to work long-term, we need an additional input of biodiesel into this system. And there's actually a very Rhode Island-specific opportunity here. Kelp is an emerging biodiesel feedstock, and we know that Rhode Island can produce a lot of kelp. So this is why we predict that a successful pilot program will drive demand and then innovation. And we can evaluate change in demand by interviewing the stakeholders shown here before and after the pilot. So can we actually make this happen? Well, we've identified that the Providence to Newport Summer Ferry is an ideal candidate. The engine doesn't need any retrofitting to use a 20% biodiesel blend that's already available from a Rhode Island company. And the engine manufacturer describes requirements for switching fuels. And crucially, this ferry operates under a public-private partnership. They receive federal funding on the basis that this ferry reduces traffic congestion and emissions from cars. And I'm telling you this to show that there are agencies involved already with interests aligned to our proposal. Now let's finish up with a vision of what could be. Picture ferries, fishing boats, tugboats, even big international tankers in Narragansett Bay, all using kelp-derived biodiesel in hybrid electric engines. This is the direction that we're going. Hybrid ferries are already used in Europe and in Seattle, and biodiesel blends are used even more widely. Our proposal for a biodiesel ferry is a very achievable step towards that future and for a cleaner ocean state.
Up next is a team from ReSeaD and MIT, Zoe Lee, Caleb Calloway, Lewis Hand, and Geneva Casalegno.
Hi, we're Team SCUP, a group of industrial designers and engineers from ReSeaD and MIT. We want to create an aquaculture system off the Block Island wind farm to better Rhode Island's ecology and economy.
The ocean is a huge part of Rhode Island's economy and culture. As of 2019, NOAA valued Rhode Island's blue economy at $2.8 billion, or 5% of Rhode Island's economy, providing 45,494 jobs. Climate change and ocean acidification threaten the future of these industries. The rise of ocean pH slows shellfish growth and raises juvenile death rates, which will negatively impact shellfish farms and the ocean itself long into the future.
Our proposal is to combine offshore aquaculture with offshore wind turbine developments to create a more resilient environment to sustain shellfish farming and fishing. Offshore wind farms already create a habitat that supports shellfish, seaweed, and fish where there would otherwise not be enough shelter. Our proposed system would expand and organize this habitat to benefit fishing practices and turbine scour protection.
We will design site-specific aquaculture systems in coordination with offshore wind developments to meet the needs of local ocean sector businesses. We propose creating a system that embraces a combination of shellfish and seaweed crops to support businesses like American mussel harvesters, Matunic oysters, and everything seaweed, starting with a 2-year pilot program to prove feasibility and logistics. Ecologically, shellfish and seaweed grow symbiotically and are both zero-input products. This system can help create a more diverse ecosystem that is more habitable to fish. Our role is to facilitate coordination across all involved parties and design systems for each region's needs.
With initial funding, we would like to set up a 2-year pilot program in collaboration with interested research institutions, harvesters, and contacts at wind farms. We anticipate initial setup costs to be around $230,000, with yearly costs including crewing, staffing, administrative costs, and consumables likely totaling around $70,000 to $100,000 per year. We will need to hire more members and consultants for our team, for example, a knowledgeable engineer to help set design parameters for the system and develop the site, an aquaculture specialist to assist with the design and implementation, and a protected species observer to approve the system and monitor the site. We will continue to apply to grants such as those from WHOI, NOAA, and the MIT Sea Grant to offset some startup costs before our system produces revenue. Once this aquaculture design is yielding harvestable shellfish and seaweed, we anticipate revenue of around $2 million annually.
We think this initial investment is worthwhile considering the many economic and ecological benefits to Rhode Island. Offshore aquaculture provides a resilient environment to sustain shellfish farming and fishing considering the threat of ocean acidification. The cooler waters offshore warrant less ocean acidification. The area also provides more nutrient flow and cleaner water which yields a stronger and healthier harvest. Our aquaculture system will expand on the fish habitation that is occurring already near the turbine structures naturally, and will encourage increased fish traffic in the area to support recreational and commercial fishermen. Additionally, ocean farming can address the severe food insecurity in Rhode Island by providing a local food source. Our plan will foster relationships between wind turbine companies and local communities who rely on the ocean, gathering more support for renewable energy growth while being equitable to the communities using this ocean space. This plan would be different from the current relationships between offshore wind companies and fishing communities. For example, Vineyard Wind has paid $37.7 million worth of compensation to fishermen for the use of ocean space for their current developments. Our aquaculture system could act as a more sustainable long-term alternative to a finite payout to fishing communities.
As we grow as a startup, we hope to integrate our system model across multiple wind farm developments. We can facilitate this growth long into the future and design systems for each region's needs, capitalizing on the expansion of turbines across the East Coast.
We believe this plan is a way for Rhode Island's blue economy to flourish in a challenging future ahead and maintain Rhode Island's cultural heritage for many generations to come.
Up next is Claire Hodson and Jess Vandenberg from the University of Rhode Island.
Here in Rhode Island, we are the ocean state. With 400 miles of coastline and an extensive network of marsh, salt ponds, bays, and inlets, the ocean is an integral part of what it means to be a Rhode Islander. Tourism, recreation, and commercial ocean use contribute billions to Rhode Island's economy each year, and our marine ecosystem nurtures thousands of species of plants, fish, and wildlife. Furthermore, many Rhode Islanders depend on our water resources for their livelihoods. Whether they're oyster farming, fishing, or participating in other marine industries, the health of our waters is crucial to the success and longevity of Rhode Island's blue economy. However, this health is in jeopardy. Many of Rhode Island's waterways are impaired due to stormwater. After heavy rain events, pollutants such as oils, heavy metals, fertilizer, and bacteria wash off impervious surfaces and into our streams, rivers, and ultimately the ocean. This pollution can cause algal blooms, beach and shellfish enclosures, and the bioaccumulation of toxic metals and chemicals in our seafood, causing ecosystem and human health issues. So what is the solution? We propose using oyster shell waste as a biofiltration media. This is a bio-based, sustainable, and low-cost approach to stormwater management. Oyster shells contain unique absorption and filtering properties, making them ideally suited to treat stormwater. Our innovation is a circular solution to stormwater pollution. Adapted from a similar approach that has been operating in the Port of Seattle, our proposal utilizes oyster shell waste in both stormwater catch basins and rain barrels. The shell is diverted from the landfill, used for up to 4 years as a biofiltration media, and then is recycled in local oyster reef restoration programs. This solution reduces water pollution while simultaneously increasing wild oyster populations, further benefiting water quality. We propose to pilot the stormwater innovation at Port, a large constituent of the Port of Providence. Port is comprised of various industries such as cement, gas and oil, and scrap metal, all of which pose risks of spillage, stormwater runoff, and other forms of pollution. In the most recent audit for the Green Marine Certificate Program, Port scored fairly low in the spill prevention and stormwater management category. By adopting our stormwater filtration system, Port can improve its standing in the certification program. We surveyed restaurants and oyster farmers to gauge interest in local availability of shell waste. All respondents were moderately to extremely interested in participating, and we identified restaurants and farmers already participating in reef restoration as the most reliable source of shell. Additionally, the Nature Conservancy expressed keen interest in incorporating our stormwater management innovation into its existing reef restoration program. We view this pilot program as a step towards achieving two short-term goals. First is promoting the use of oyster shell waste in stormwater management for both commercial and municipal systems. And second is encouraging Port to continue to move towards greener practices. Over the long term, we view this pilot as a means of launching the entirety of the Port of Providence into a cleaner, greener, and more sustainable future.
Up next is Maran Bakare from ReSeaD.
Hello, my name is Maran Bakare, and I'm interested in the intersection of public transit and local food waste. The Rhode Island Public Transit Authority and the Rhode Island Department of Transportation are focused on moving people by means of bus, rail, and ferry. However, only 3% of Rhode Island residents use public transportation. Reports emphasize the dangers of exhaust and particulate matter, and Rhode Island neighborhoods are suffering from unhealthy emissions. The transportation system is the top contributor of greenhouse gas emissions in Rhode Island, as 92% of all transportation-related emissions come from highway vehicles and personal cars. Therefore, bold action must be taken in transforming the transportation sector in order to reduce greenhouse gas emissions by electrifying buses and increasing ridership, but to also do much more, such as promote public health, generate green economic development, and increase equitable mobility options. As a response, I am proposing the design of a zero-waste mobility hub that contains a vibrant mix of uses to connect people to community activities, to grow the economy and quality of life while ensuring environmental sustainability in Rhode Island. It will contain a bus charging station, bike share, and scooters, as these options are an important way to make short trips and connect people to transit. In addition, retail and services help maximize the hub's functionality, making it a destination in and of itself. The hub is designed as an attractive, walkable destination, making transit more compelling, as the hub implements interesting ceiling, vault, and ground conditions, as well as dynamic color experiences throughout that revitalize the area. The mobility hub employs a design for disassembly strategy, where its component parts can be dismantled, reconfigured, and easily added onto so that the structure grows with the changing needs of the area and with the increasing services over time. It will be built using prefabrication methods, and the consistent design elements expedite the construction process while minimizing the effect on the environment and the community. I am proposing to locate the mobility hub in the Upper South Providence. Locating the mobility hub in this site will not only strategically activate the community and facilitate ridership, but its population density provides opportunity to tie in local food waste, as the mobility hub can serve as a convenient compost drop-off site to the 7,000 hospital employees, neighborhood residents, and CCRI students, potentially becoming a community catalyst for composting and food waste diversion. The Upper South is also a low-income community with little green space, poor sidewalk conditions, and limited mobility options. Negative impacts of past transportation investments have disproportionately fallen on low-income neighborhoods and communities of color. At present, 22% of Rhode Island minority residents have access to frequent transit. The electrified transit options and income-generating program offered by this proposed mobility hub can begin to amend some of these long-standing inequities. In addition, the Rhode Island Institute of Health reports that 7 out of 10 adults in Southside Providence do not eat the recommended 5 servings of fruits and vegetables a day. Therefore, an important amenity of the mobility hub is its farmers market that houses locally focused fresh food in order to increase access to fresh produce in the area, community, and enhance public health. The movement towards electrification of transportation system is complemented by the job creation potential. Almost half of the current workforce in energy efficiency has a high school diploma or less, and these jobs pay on average 8 to 19% more than area median wages. This movement is also projected to have substantial health and safety benefits for Rhode Islanders. Next steps for implementing this solution include acquiring funding and establishing partnerships with stakeholders. The Transportation and Climate Initiative Program will allow Rhode Island to invest almost $200 million for modernizing transportation, improving public health, addressing environmental inequities in low-income communities, and protecting residents from the impacts of climate change. Sustaining and increasing ridership is at the core of RIPTA's mission, and they currently have 3 battery electric buses, 62 hybrid electric buses, and is preparing to purchase 17 BEVs. Farm Fresh Rhode Island can participate by operating the farmers market in the hub and play an important role in increasing the availability and accessibility of local foods. Lastly, Zero Waste Providence can participate by providing advice and resources to the neighborhood's residents looking to participate in the Mobility Hub's composting program, as they are advocates of local composting in cities. With this ambitious but actionable framework, I hope that I would be joined in creating a new mobility vision that sets us on a path to a clean transportation future that promotes economic development and equitable benefits for all Rhode Islanders. Thank you.
Up next is a team from Brown University: Emma Kaufman, Graham Keeley, Mita Austin, and Jasmine Gabor.
Hi everyone, thank you for coming to our presentation. Our project is a Kelping Hand for Rhode Island, and our goal is a processing plant to lower the barriers to integrated multi-trophic aquaculture using kelp in Rhode Island. So Rhode Island has really high potential for a big kelp industry, but there are a couple barriers that are preventing the expansion of the space. The first of which is that the permitting process for new kelp farms is really arduous, and there are a lot of hurdles to jump through. And some homeowners along coastlines have a negative view of aquaculture, which also hampers the permitting process. And then Rhode Island does not have much current market demand for kelp, especially compared to countries like China and South Korea, where a lot of kelp is currently being produced. And then Rhode Island and southern New England in general also do not have much processing capacity for kelp, and kelp does not stay fresh for very long, so the processing is a necessary step to make sure it stays shelf stable. And then finally, Rhode Island does not have the same kelp growing community that bigger growth states like Maine and Connecticut and Alaska do. And so through a lot of conversations with people both in the kelp and aquaculture space, we got 2 main takeaways, which are that people recognize that the kelp industry is growing really rapidly, but they also recognize that Rhode Island cannot take advantage of that rapid growth because of the lack of processing infrastructure. And from some conversations with people in Maine, we found that they really are capitalizing on how quickly demand for kelp is growing because they have local processing facilities. And so that is what led us to our proposal, which is to add local flash freezing facilities for kelp within Rhode Island. And so the way the process works is that the processing facility sends seeds to oyster farmers. Oyster farmers plant kelp during their off-season. During the winter, harvest it in the late spring to summer, and then sell it to the processing facilities where it's freeze-dried and then sold as is or sent on for further processing. And then the facility sends the seeds back to the farmers to repeat the cycle again. And the benefit of a process like this is that having oyster farmers plant kelp on their existing farms gets around a lot of the permitting hurdles with new kelp farms, and then freeze-drying the kelp really extends the shelf life so that it can be sold to a wider range of places, or it can be sent further on to secondary processing facilities where it can become a higher value product. And so then we did a quick breakdown of the kelp market size in Rhode Island using the acres of land leased for aquaculture, how much kelp can be produced per acre, and the price of that kelp. And we found that if all of the land currently used for aquaculture is utilized for kelp, Rhode Island could grow 2.6 to 10.6 million pounds at a value of $1.1 to $7.4 million per year. And of course, this is assuming that all land will be used, which is not likely. So we made a couple assumptions that there would be 20% adoption by oyster farmers initially, which tracks with the conversations we had with oyster farmers, and that the amount of kelp grown per acre would be somewhere in the middle of that range on the left side. And so using those assumptions, we found that Rhode Island could produce 1.1 million pounds of kelp at a value of $530,000 per year. And this puts Rhode Island in line with bigger kelp growing states like Maine and Alaska, and at a cost to grow of around 50 cents per pound, this could be a low activation energy profitable way for oyster farmers to add a new crop. And so then the benefits of integrating kelp growth with oyster growth are not just getting around permitting. They utilize each other's waste, so it reduces eutrophication and ocean acidification and also increases shellfish production. And then the kelp by itself is a near permanent carbon sequestration method, and because this kelp is being planted in the oyster off-season, it's a method of job creation for the oyster farms. And so finally, the impact of a proposal like this is environmental, economic, and health-oriented. And some metrics we could use to measure the success of this are measuring ocean acidification in these farms and tracking marine biodiversity to see if it increases where more kelp is grown. And then also keeping track of the number of jobs created and what the total market size is, and how many oyster farmers are adopting this new growing method would be helpful metrics to track. And then finally, we just want to thank SeaAhead and the BlueGreen Innovation Challenge. We also want to thank all the people we talked to for being so generous with their time. And then we want to give a special thanks to Professor Fran Slutsky for advising us throughout the whole process. Thanks.
Up next, we have a team from WPI and Northeastern University, Marcello Nicoletti and Clayton Richardson.
We live in a world where data is collected on everything, from Google searches to car traffic.
But very little data is collected on the most valuable resource on Earth, our oceans. Hi, my name is Marcello Nicoletti. I'm a mechanical engineer and project lead.
And I'm Clayton Richardson, an architectural designer, and we are ReSeaD,
a startup focused on bringing renewable energy-powered data collection to Rhode Island's blue economy. The problem addressed in this project begins with a limited knowledge on the ocean, both around the world and offshore Rhode Island. Ocean exploration and research is key to monitoring and understanding the changing environment. However, the current data collection methods come with a high cost for the development of the technology and deployment and operation of the system. One of the three most pressing needs for data in Rhode Island is for the installation of offshore wind farms. BOEM requires a site assessment for each installation before construction, which can take up to 5 to 6 years. To put this in perspective, Ørsted's Revolution Wind Farm is one of the 6 offshore wind projects to be installed near Rhode Island shore. The commercial fishing industry relies on these site assessments to minimize impact on key species, but would also benefit from data-driven fishing and management.
Here is a breakdown of some of the leading technology used in the Northeast, with 2 types shown, moored buoys and autonomous vehicles. The key takeaways are that these systems are expensive, rely on non-replenishing power sources, and utilize electronics that are vulnerable in a corrosive marine environment.
Here is our solution, a Deepwater Data Collection Buoy, or DCB, that aims to maximize data coverage through a cost-effective design, while surviving long deployments without maintenance. To minimize the resupply of batteries, the DCB is powered by harnessing ocean energy. A novel mechanical power takeoff system was designed for maximizing power generation across a range of sea states. A continuous variable transmission transmits a constant output while adapting to changes in input power, increasing the overall power generated. This power takeoff system can operate at both the water's surface or when submerged. The variable depth control allows for full water column analysis and is used to transmit data at the water's surface. In doing so, there's a chance of whales becoming entangled in the anchor cable. This is addressed using the depth control. Once the whale is in range of the sensors, the DCB submerges and alerts the buoy in the vicinity to submerge as well, before returning to operation.
The biomarine anchor supports the function of the deadweight anchor, and is designed for quick installation while avoiding the need for removal due to its material properties. We interviewed Arc Marine, developer of the Reef Cube, which provides the necessary conditions for new habitat growth. However, no product on the market is designed specifically for anchors or moored systems.
The performance metrics are related to our design goals and include avoided costs and emissions, volume and cost of data, and the system's impact on marine research and the blue economy. The DCB's renewable energy source adds value by prolonging operations, minimizing the cost of battery maintenance, and allows for the use of additional sensors due to the increased available power. The depth control allows for data to be collected at a specific depth, increasing precision and efficiency of the data collection process. I want to thank SeaAhead, the sponsors, and our mentors for helping us throughout this project.
This experience has been challenging yet rewarding, and we're excited for the future of marine data collection and a better understanding of our oceans. I'm Clayton.
And I'm Marcello, and we are ReSeaD.
Up next is a team from UMass Lowell. We have Sarvesh Honda, Ryan Baseline, Editha Rasu, and Ali Semarisi.
Hi, my name is Sarvesh Honda and I'm the founder of MissionHydro, where we are developing a long-duration energy storage system leveraging green hydrogen technology. Rhode Island is home to the very first offshore wind farm in the country, Block Island, and throughout this decade, this state is expected to lead the country in this adoption of renewables as it works towards achieving its 100% clean energy goal. To avoid a situation like Texas experienced in early 2021, however, this drastic shift demands an answer to a very important question. Is our grid ready for renewables? You see, renewables such as offshore wind and solar suffer from a major problem, intermittency, which makes their integration into the grid very challenging. To balance supply and demand, the deployment of energy storage is required. However, the current offerings of energy storage systems such as lithium-ion batteries suffer from elevated costs, short durations, and high degradation. To support the renewable grid, utility companies will require durable and longer duration storage systems, and this is where our hydrogen-powered solution steps in. Our solution leverages existing hydrogen fuel cells and a proprietary electrolyzer technology to enable the storage of excess renewable energy in the form of hydrogen. This hydrogen is stored on-site, which can be converted to useful energy on demand through the integrated fuel cell or be sold as green hydrogen. We're accomplishing this by using a dual-stack system that can recover waste heat from the fuel cell and a unique electrolyzer catalyst that work to improve energy efficiency. We believe this can result in an increase in the overall return on investment for our end users. And with the use of fuel cells, we're able to produce electricity with virtually no carbon emissions while providing a longer lifespan and over 3 times the energy density of lithium batteries. The reduction of toxic metals inside fuel cells also helps ensure a low carbon footprint while making end-of-life disposability cleaner for our communities. Our proposal includes multiple assumptions that include projections like the rising demand for seasonal storage systems and the need for a more decentralized grid. Additionally, we believe there's a major value for green hydrogen to decarbonize the traditional gas-dependent industries such as fertilizers and steel. Rhode Island is home to multiple projects that can leverage our concept without major infrastructure changes. For example, National Grid's Wakefield substation acts as an ideal site where power sourced from the Block Island wind farm can be stabilized using our system, and then transmitted with an improved capacity factor to the Narragansett community. And we're very confident that such projects can become a reality given the rapid reduction in levelized costs of renewables and the multiple revenue opportunities that are presented by green hydrogen. With corporate sustainability targets in sight, the market for green hydrogen made from renewables is growing fast as companies aim to eliminate natural gas. This demand, along with the declining cost of fuel cell hardware, will allow us to bring our design to market very cost effectively. We also believe that BlueGreen sponsors and funding can play a key role in allowing us to overcome a handful of the potential impediments in our journey, such as component sourcing and siting delays. And provided the rapid growth in clean energy acceptance and the hydrogen supply chain, our solution is able to tie together a very diverse set of stakeholders from other businesses to government bodies and to the local community. And as our solution is adopted, the state's ability to offset natural gas power production and in turn the reduction of carbon emissions will help determine our impact. In addition, the creation of energy sector jobs will also be an extremely valuable aspect of our project. And to conclude, here's a look at our 3-year launch plan for our startup initiative, where we intend on leveraging the expertise and platforms provided by program partners to conduct beta and pilot testing. We hope you'll support us in turning our concept to a reality. Thank you very much for listening.
And finally, we have Alexander Camper from Brown University.
By running a low current through a boat's metal hull, aquatic industries have long exploited a simple chemical principle to prevent corrosion and marine growth. In 1976, architect Wolf Hilberts reconfigured this technology to build limestone structures layer by layer over a metal frame of any size or shape. Using lower currents, he could grow structures with the same material and thermal properties as heavy-duty reinforced concrete. Hilberts called this material Biorock to emphasize its similarity with living organisms like coral and shellfish, which build their shells and skeletons in a similar manner. He had developed a self-generating, self-repairing construction material that got stronger with time. Hilbert's Biorock was enthusiastically embraced by the architectural community. In the spirit of their time, mid-century architects wanted to realize utopia through the built world. They imagined fantastic underwater cities and artificial islands, all crafted from the material. Rhode Island's first submarine metropolis is probably a few years down the road, but the applications for Biorock today are numerous. Biorock reefs are ideal habitats for many aquatic species, and have been used to restore aquatic ecosystems in every climate. They are ideal habitat for fish and shellfish, meaning they can be used where Rhode Island's natural fisheries and reefs have been degraded, as well as for fish, shellfish, and seaweed farming. Shoreline erosion is a growing concern for Rhode Island homeowners and governments. Biorock reefs are a cost-effective method for not only protecting our shorelines, but rebuilding them as well. Due to low material and transport costs, Biorock breakwaters are faster and cheaper to build than conventional structures. By refracting rather than reflecting wave energy, they avoid the problems of erosion and undermining that plague solid breakwater designs. Biorock presents solutions to many of the problems Rhode Island is facing today. So how do we apply them? And in the green economy, they help to realize how can we include all Rhode Islanders in the just transition. Rhode Island is home to the first offshore wind farm in the country. During off-peak hours, when more energy is produced than needed, electricity could be diverted to aquaculture setups enhanced by Biorock. Any additional energy needs could be met by floating solar panels or wave energy converters. Weather conditions and the high cost of infrastructure are the greatest operational challenges to open ocean aquaculture. Biorock reefs would not only buffer fish enclosures from waves, but provide habitat for wild species as well. Closer to shore, these setups could include seaweed and shellfish farming. Such Biorock polycultures would generate local, sustainable food and revenue, while providing critical environmental services like biological water filtration and coastal protection. In its early stages, this aquaculture venture should leverage Rhode Island's diverse cast of private industries, nonprofits, and universities. Shellfish RI and the Ocean State Shellfish Cooperative would be obvious allies. Artistic and experimental projects could be performed in collaboration with ReSeaD's architecture and sculpture departments or URI's marine sciences programs. CCRI and technical schools could launch training programs to introduce students into this growing field. As the aquaculture venture expanded and Biorock became more familiar, the venture could expand into construction and government contracting. Instead of costly, inefficient seawalls, homeowners and municipalities could construct cheap Biorock reefs that protected their shorelines while enhancing biodiversity. A green and expanded aquaculture industry would empower a new generation of maritime workers in Rhode Island. Ports and land-based industry would adapt to new supply chains, creating yet more opportunities for green job creation. Imagine Farm Fresh RI processing fish waste and selling it as high-nitrogen fertilizer for local vegetable farmers. Likewise, shells from bivalve processing might become an important source of calcium for hydroponic operations like Gotham Greens. The COVID-19 epidemic has ignited questions about the future of employment in Rhode Island and the US at large. People want good jobs, but they also want work that won't poison their bodies or the planet. The phased deployment of Biorock technology would multiply the opportunities available to a healthy and well-compensated workforce in a greener Rhode Island. Let's recapture Biorock's utopian spirit and begin building the world we want to live in.
All right. Thank you so much to all the finalists. Those were great. Now we're going to open the poll, and we want to hear from our audience. Which pitch did you think was best? We'll keep it open for a couple minutes. And here is just a refresher on each of the pitches. So the winner is Team Scup for their aquaculture off of wind farm sites.
Congratulations.
And now I will turn it over to Alyssa to announce the grand prize winners, starting with third place.
So we are now ready for our judges awards. As a reminder, the third place prize is a $1,000 prize. And at this time, I would like to award third place to ReSeaD for their renewable energy powered offshore data collection platform. The judges felt that the additional knowledge that would be gained by having systems like this out in the water, made you all deserving of this award. And so we'd like to congratulate you on all the hard work and effort that you put into putting your project together. So congratulations. So second place award now is a $5,000 award. And we would like to award that to the Oyster Shell Valorization Team, Claire and Jessica. So congratulations on this award. The judging panel wanted to acknowledge that you did a great job finding a solution that was being implemented in a different location within the US, and finding and adapting it to the situation here in Rhode Island. However, they did want to call out that part of the reason that this is a second place and not a first place award is that the team had some work to do with engaging the community and bringing in stakeholders to collaborate on that program. And so this is something, of course, that we'll be continuing to work with that teams on in order to make sure that these solutions come into fruition. And now first place is a $10,000, our $10,000 grand prize. That feels so fun to say, is being awarded now to Team Scuppers, who is also the winner of the People's Choice Award. So congratulations to this team. Yay, we're so delighted with the work that you've put together here. We thought the judging panel would like to acknowledge the excellent job you did in finding a real opportunity, an under-acknowledged opportunity here in Rhode Island, and for laying out the pieces for how to make that idea successful. And really importantly, for engaging with all the different levels and layers of collaborators and contributors that would be required in order to make this project successful. And the judging team will be in touch with you all, because we are really excited to help you bring this project to fruition and to work with you as you consider what next steps to take. You know, looking at us from the SeaAhead perspective, we're working now on our next challenge. And so we are in the planning stages of an ocean data challenge, which will be the follow-up to this program. That challenge will be announced, you know, the opening of that challenge will be announced at a later date, but that is a collaboration between us and a community similar to our Northeastern community down in the Gulf Coast region. And so you'll hear more about that soon. If that's something that you would be interested in helping to support, please reach out either to Taylor or myself, and we would be delighted to loop you in on that when it, you know, as we get it prepared for launch.
We didn't prep the finalists for this, but we'd love to open it up for questions. Maybe we could moderate that in the chat, and if you have any questions, we can pass it along to the finalists, and they can chime in.
I think we had, so the ReSeaD team in the chat, they were talking about, and I think you answered this in the chat, but if you could answer it on video, that'd be fantastic. The lobster industry in Maine is raising huge political opposition to floating offshore wind projects. Can you speak to the role your anchors might have in mitigating the impact on the lobster biome?
Yeah, sure. So like I said in the chat, between the materials used in the biomarine anchor and the cavities or holes, you could strategically select the materials and the size of those holes to provide shelter and the nutrients needed for certain fauna species to attract, you know, other species of prey for food. So you pretty much design the anchor to create habitat, or at least attract species.
So Keydell asked for those finalists to have a plan. If you know what you're going to do with funding, or what you're hoping to do, your next steps are. And I know some of you might be still kind of on cloud 9, so you might not know. But for those of you who are thinking about that, if you want to unmute and ask or an answer, that'd be fantastic.
Hi, I'm from Team Scuff. I'll start off by answering, I guess. We are completely in shock right now. Like we said in our video, we're planning to set up a pilot program somewhere off the Rhode Island coast of just a starting aquaculture system with integrated seaweed, as well as the oysters and mussels and other things. So yeah, continuing to work with the stakeholders we've been talking to get that set up. So yeah, thank you.
So no vacation, you're not taking a vacation or doing a team building exercise?
In Hawaii or something?
Exactly. They should do a team building exercise. We need to go on a yacht to really take in all of the ocean, you know.
Awesome. Rob Cortell did ask if winning teams are interested in working with parties in Virginia or on the Chesapeake. Rob, do you want to expand a little bit and make a connection there?
Sure. So, you know, we have the Virginia Institute of Marine Sciences down here, which is doing a lot on the data side, analytics and autonomous underwater analytical vessels. And then, of course, Dominion Resources is building a wind power project off of the coast here, and has had all the approvals and everything else. So at least two of the teams are pretty relevant to that. And then of course we are the oyster kings down here. So we have a lot of oyster shells. So that's why it looks to me like it might be a good place to talk.
It looks like we've got one more question, which I think is a really good one to close on, from Todd McGuire at 11th Hour Racing. Could some of the finalists just elaborate on what you learned from this experience?
I mean, I guess it's real general, but there's great ideas, and then there are the ideas that become a reality and actually work, and those end up working because everything was thought out from beginning to end, from stakeholder to end user, and yeah.
Add on to that, I'd say it was really valuable to learn how interconnected all of the sectors are, kind of how everyone plays a role, and how vital it really is to kind of have these sectors working together in a positive way.
I think I was really blown away by the way the challenge was set up and made to make you think of those things though too, Clayton. Like you really couldn't come up at it with a single solution to one problem. You had to think about the whole sector and the entire region, which was phenomenal. It was just really well designed. So SeaAhead, thank you for that. It's been wonderful watching it develop, and these videos have been fantastic.
Yeah, it was really fun seeing the finalists progress, and we're really looking forward to doing more challenges in the future.
Yeah, from us at 11th Hour, I mean, we're really impressed with the how the challenges came through and how professional the development was. So congratulations to you all, and look forward to seeing what you come up with in the future and following these projects.
Cool. Yeah, and then we'll just before we wrap up, we'll put in one last plug for SeaAhead, and we are currently have applications open for our Blue Swell incubator. That's being run out of CIC Boston for early stage startups that want support on their path toward commercialization. Comes with mentorship as well as a $35,000 non-dilutive grant. So if you've got a startup and you want support, help it as you grow, check that out.